below. In this lecture we'll find out the value of angle theta. In the drawing we have triangle ABC, side CA equals to side CB. That is to say, triangle ABC is an isosceles triangle. In addition, we know that this angle ACB equals to 20 degrees in size. This angle NAB equals to 50 degrees in size, and this angle MBA equals to 60 degrees in size. Our mission is to find out the size of this angle theta, that is also defined as angle NMB. So first of all, I will copy this triangle ABC in a new page and we will analyze it. Actually, this is triangle ABC that I copied from the original drawing. This angle ACB equals to 20 degrees and side CA equals to side CV. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides we have those two angles that must be also equal to each other. So if this angle equals to theta, then the other angle must be also equal to theta. And we know the sum of the angles in any triangle is equal to 180 degrees. Theta plus theta is 2 theta, so 2 theta plus 20 degrees in triangle ABC must be equal to 180 degrees. So I write it down. In triangle ABC, 2 theta plus 20 degrees. In total, the sum of those three angles must be equal to 180 degrees. We subtract 20 degrees from this equation and we get that 2 theta equals to 180 minus 20, it is 160 degrees. We divide this equation by 2 and finally we get that angle theta equals to 160 over 2, it is 80 degrees. So angle theta equals to 80 degrees in its size. This is angle theta, it is equal to 80 degrees. This angle theta equals to 80 degrees. Okay. So those two angles are both theta. Each of them is equal to 80 degrees in its size. So this angle theta equals to 80 degrees, but part of angle theta, that is to say angle NAB, it is already equals to 50 degrees, therefore the missing angle must be equal to 30 degrees. Again, in order to complete the size of angle theta to 80 degrees, the missing angle here must be equal to 30 degrees. Likewise, this is an angle theta that is equal to 80 degrees. But part of angle theta, angle MBA, it is already equal to 60 degrees, therefore the missing angle here must be equal to 20 degrees. In order to complete the size of angle theta to 80 degrees, the missing angle here must be equal to 20 degrees. In the next step, we will focus on triangle NAB. So I copy triangle NAB in a new page and we will analyze it. angle NAB equals to 50 degrees in its size. And this angle NBA equals to theta, that is 80 degrees. Here, those are the two angles, NAB and NBA. So this is the angle NAB that I copied from the original drawing, and we define the missing angle as theta. The sum of the angles in the triangle NAB is equal to 180 degrees. That is to say 50 degrees plus 80 degrees plus angle theta. In total, the sum of those two angles must be equal to 180 degrees. 50 plus 80 is 130, so 130 plus theta equals to 180 degrees. We will subtract 130 degrees from this equation, and we get that theta equals to 180 minus 130, it is 50 degrees. So here, this is angle theta, that is equal to 50 degrees. And angle theta, it is also defined as angle NAB. This is angle NAB also. So we can write here that angle NAB is angle, it's actually angle A and B. This is angle A and B, that is equal to 50 degrees. So angle A and B equals to 50 degrees in its size. We will continue to focus on this triangle, triangle A and B. This triangle, those two angles are both equal to 50 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, there are equal sides. So those two sides that are located in front of those two equal angles must be equal to each other. That is to say, side AB equals to side NB. AB equals to NB. So I can write here that side AB equals to side NB, and here also side AB equals to side NB. Okay. In the next step, we focus on triangle MBA. So I copy triangle MBA in a new page and we'll analyze it. Angle MAB equals to 80 degrees. And this angle MBA equals to 60 degrees. So actually, this is triangle MAB that I copied from the original drawing. Those are the two angles MAB and MBA. So we define the missing angle. This missing angle is theta. The sum of the angles in triangle A and B equals to 180 degrees. That is to say, 80 degrees plus 60 degrees plus the missing angle theta. In total, the sum of those two angles must be equal to 180 degrees. 80 plus 60 is 140. So 140 plus theta equals to 180 degrees. We'll subtract 140 degrees from this equation. And finally we get that angle theta equals to 180 minus 140, it is 40 degrees. So this is angle theta that is equal to 40 degrees in its size. Angle theta is actually also angle A and B. So angle A and B equals to 40 degrees in its size. So this is angle A and B that is equal to 40 degrees in its size. In the next step, we'll do a construction. That is to say, from point B, we'll draw line segment BD on CA. Again, from point B, we'll draw line segment BD on CA in such a way that BD will be equal to BA. Okay. Repeat again. This line segment BD equals to AB according to our construction. So I write it here. BD or DB equals to AB according to our construction. So we have here two equations. From one side, AB equals to NB. EB equals to NB. But from the other side, AB equals to AB also equals to BD. So we can write here AB equals to BD. And from this equation, NB equals to AB equals to BD, we derive that NB equals to BD. Okay? NB equals to BD. NB equals to BD. Here, side NB equals to side BD. Those two sides are equal to each other. In the next step, we focus on triangle ADB. This triangle, so I'll copy triangle ADB in a new page and we will analyze it. So, actually this is triangle ADB that they copied from the original drawing. This angle DAB equals to 80 degrees. And according to our construction, side AB equals to side DB. AB equals to DB according to our construction. Again, we have the rule that in front of those two equal sides, they are equal angles. So those two angles are located in front of those two equal sides, therefore those two angles must be equal to each other. But this angle equals to 80 degrees, therefore the other angle must be also equal to 80 degrees. That is to say, we found out that angle ADB equals to 80 degrees in size, so I can write here that this angle ADB equals to 80 degrees in its size. We continue to focus on triangle ADB. And on triangle ADB, the sum of the angles must be equal to 180 degrees. We define the missing angle as theta, so 80 degrees plus 80 degrees plus the missing angle theta. In total, the sum of those three angles must be equal to 180 degrees. 80 plus 80 is 160, so 160 plus theta equals to 180. We subtract 160 degrees from this equation, and finally we get that the missing angle theta equals to 180 minus 60, it is 20 degrees. So here this angle theta equals to 20 degrees. Angle theta, it is actually also defined as angle ABD. Angle ABD equals to 20 degrees, so we write in the original drawing that this angle ABD equals to 20 degrees in its size. So we have here the small angle DBA equals to 20 degrees in size. The big angle MBA equals to 60 degrees in its size. It is very easy to see from the drawing that the big angle MBA minus the small angle DBA, the difference between those two angles must be equal to the missing angle, angle MBD. So I write it down. The big angle, this angle MBA, that is equal to 60 degrees in its size, minus the small angle, that is actually angle DBA, that is equal to 20 degrees in size. The difference between those two angles must be equal to the missing angle, that is angle MBD. I'll do it again. The big angle MBA is equal to 60 degrees in size minus the small angle DBA that is equal to 20 degrees in size must be equal to the missing angle MBD. So 60 minus 20 is 40, so we found out that the missing angle MBD equals to 40 degrees in its size. So I write it down in the original drawing that this angle MBD equals to 40 degrees in its size. In the next step, we focus on triangle DMB. So I'll copy this triangle DMB in a new page and we'll analyze it. We have already found out that this angle DMB equals to 40 degrees in size. And we just right now found out that angle DBM equals also to 40 degrees in size. So actually, this is triangle DMB that I copied from the original drawing. Those two angles are both equal to 40 degrees, therefore they are equal to each other. According to the rule that in front of equal angles in the triangle there are equal sides. Those two sides are located in front of those two equal angles, therefore they are equal to each other. That is to say, side DM equal to side DB. DM equals to DB. So we can write here that dm equals to db and here also this is side dm that is equal to side db. In the next step we will join points D and N together by a straight line. And we will focus on the green triangle, triangle DNB. So I copy this grand triangle DNB in a new page and we'll analyze it. So actually, this is triangle NDB that I copied from the original drawing. What is the size of angle NBD? What is the size of this angle NDB? From the drawing it is very easy to see that the size of this angle NDB it is equal to 40 degrees plus 20 degrees. Okay? So 40 degrees plus 20 degrees it is 60 degrees. So the size of this angle NBD equals to 60 degrees. And we have already found out that NB equals to dB. Side NB equals to side dB. Again, we have the same rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, we have those two angles that must be equal to each other. So if this angle is theta, then the other angle must be also equal to theta. The sum of the angles in triangle DNB must be equal to 180 degrees. Theta plus theta is 2 theta plus 60 degrees. In total, the sum of those three angles must be equal to 180 degrees. We'll subtract 60 degrees from this equation. And finally, we get that 2 theta equals to 180 minus 60, it is 120. 2 theta equals to 120 degrees. We'll divide this equation by 2 and finally we will get that angle theta equals to 120 degrees over 2, it is 60 degrees. So we found out that this angle theta equals to 60 degrees in its side, and this angle theta is also equals to 60 degrees. That is to say, in triangle NDB we have three angles that all of them are equal to 60 degrees in their sizes. Therefore, triangle NDB is an equilateral triangle. So I write it down here. Triangle NDB is an equilateral triangle. And we have the rule that all the sides of an equilateral triangle are equal to each other. So in the equilateral triangle DNB, side DN equals to side NB equals to side DB. So I write it down here. Side DN equals to side NB equals to side DB. Side DN equals to side NB equals to side DB. So we'll focus on those two equations. From one side, dB equals to dm. from the other side, from this equation, we derive that dB also equals to dN. So you can write here that dB equals to dN. And from this equation, dm equals to dB equals to dN, we will derive that dm equals to dN. Okay? dm equals to dN. dm equals to dN. Here, side dm equals to side dN. In the next step, we'll focus on this side of the straight line CA at point D. Okay. So, which angles we have on this side of CA at point D? We have this angle that is equal to 80 degrees, and this angle it is one out the three angles of the equilateral triangle NDB, therefore it must be equal to 60 degrees, and we have this missing angle MDB is the missing angle. So here we have one angle that is equal to 80 degrees in its size, the other angle equals to 60 degrees in its size. So this is the straight line CA at point D. We have on this side of the straight line CA at point D, we have 80 degrees plus 60 degrees plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. 80 plus 60 it is 140. Therefore, in order to complete the sum of the angles on this side of CA at point D to 180 degrees, the missing angle here must be equal to 40 degrees. Okay, so I found out that angle MDB, this angle equals to 40 degrees in its size. So here, this is angle MDB. This is equal to 40 degrees in its size. In the next step, I will copy triangle MDN in a new page and we will analyze it. Here, angle MDN equals to 40 degrees. This is triangle MDN that I copied from the original drawing. This angle MDN equals to 40 degrees in its size. And we already found out that dm equals to dn. So here, side dm equals to side dn. Again, according to the same rule, that in front of those two equal sides, we have equal angles. That is to say, these angles that are located in front of those two equal sides must be equal to each other. So if this angle equals to theta, then the other angle must be also equal to theta. The sum of the angles in triangle MDN must be equal to 180 degrees. Theta plus theta is 2 theta, so 2 theta plus 40 degrees must be equal to 180 degrees. We subtract 40 degrees from this equation, and finally we get the 2 theta equals to 180 minus 40, it is 140. 2 theta equals to 140 degrees. We divide this equation by 2, and finally we get that the missing angle theta equals to 140 degrees over 2, it is 70 degrees. So this is angle theta that is equal to 70 degrees in its size. Angle theta it is actually also defined as angle DMN, so I found out that angle DMN equals to 70 degrees in its size. So in the original drawing we have this angle DMN that is theta, it is equal to 70 degrees in size. So this angle DMN, this is actually angle DMN that is equal to 70 degrees in size. So the big angle DMN, this minus the small angle DMB, that is equal to 40 degrees in size. So the difference between the big angle DMN minus the small angle DMB must be equal to the missing angle theta. Again, the big angle minus the small angle must be equal to the missing angle theta, that is the angle that we are looking for. So I write it down. The big angle, that is actually angle DMN, that is equal to 70 degrees in its size, minus the small angle, that is actually angle DMB, that is equal to 40 degrees in its size, must be equal to the missing angle theta, that is actually defined also as angle NMB. So I repeat again. The big angle DMN that is equal to 70 degrees in size minus the small angle DMB that is equal to 40 degrees in size must be equal to angle theta, that is the angle that we are looking for. So 70 minus 40 is 30 degrees. So I found out that the missing angle theta, that is also defined as angle NMB, equals to 30 degrees in its size. And that is the answer to the question. Okay, this is angle theta that is equal to 30 degrees in its size. In the next step, I'll summarize the lecture. In this lecture, our mission is to find out the size of this angle theta, that is also defined as angle NMB. It is given us the question that this is triangle ABC, side CA equals to side CB, therefore triangle ABC is an isosceles triangle. In addition, you know that this angle ACB equals to 20 degrees in size. This is angle NAB that is equal to 50 degrees in size, and finally this angle MBA equals to 60 degrees in size. Again, our mission is to find out the size of this angle theta. So in the first step, I copied triangle ABC in a new page and we analyze it. This is triangle ABC that I copied from the original drawing. This angle ACB equals to 20 degrees according to what is given in the question, and side CA equals to side CB. And we have the rule that in front of those two equal sides, there must be those two equal angles. In front of equal sides in the triangle, there are equal angles. So those two angles must be also equal to each other. So if one angle is theta, then the other angle must be also equal to theta. And we have the rule that the sum of the angles in any triangle is equal to 180 degrees. So therefore in triangle ABC, theta plus theta is 2 theta, so 2 theta plus 20 degrees must be equal to 180 degrees. We subtract the 20 degrees from this equation, and finally we get that 2 theta equals to 180 minus 20, it is 60, so 2 theta equals to 160 degrees. We divided this equation by 2 and finally found out that angle theta equals to 160 over 2, it is 80 degrees. So those two angles, each of them are equal to 80 degrees. Okay? So those two angles, each of them is equal to 80 degrees. So this angle theta equals to 80 degrees, but part of angle theta, angle NAB, it is already equals to 50 degrees, therefore the missing angle here must be equal to 30 degrees. In order to complete the size of angle theta to 80 degrees, the missing angle here must be equal to 50 degrees. Likewise here, this is angle theta, that is equal in total to 80 degrees, but part of angle theta, that is to say angle NBA, it is already equals to 60 degrees, therefore the missing angle here must be equal to 20 degrees. In order to complete the size of angle theta to 80 degrees, the missing angle here must be equal to 80 degrees. In the next step, I copy triangle NAB in a new page and analyze it. This is triangle A and B that I copied from the original domain. Angle NAB equals to 50 degrees and angle NBA equals to 80 degrees. Those are the two angles. We define the missing angle as theta. In triangle A and B, the sum of the angles must be equal to 180 degrees. That is to say 50 degrees plus 80 degrees plus theta. In total, the sum of those three angles must be equal to 180 degrees. 50 plus 80, it is 130, so 130 plus theta equals to 180 degrees. We subtracted 130 degrees from this equation and finally we found out that angle theta, the missing angle theta equals to 180 minus 130 is 50 degrees. And this angle theta equals to 50 degrees, but angle theta it is defined also as angle A and B. Therefore, angle A and B equals to 50 degrees. This is angle A and B that is equal to 50 degrees in its size. We continue to focus on this triangle A and B. In this triangle A and B, those two angles are equal to each other. And we have the rule that in front of equal angles in that triangle, they are equal sides. So those two sides that are located in front of those two equal angles must be equal to each other. That is to say, side AB equals to side NB. AB equals to NB, so you can write here also that side AB equals to NB, and here also side AB equals to side NB. Those two sides are equal to each other. In the next step, we focus on triangle A and B, so I copy triangle A and B in a new page and we analyze it. This is triangle A and B that I copied from the original domain. Angle MAB equals to 80 degrees and angle MBA equals to 60 degrees. Those are the two angles. We define the missing angle here as theta. The sum of the angles in triangle A and B equals to 180 degrees. That is to say 80 degrees plus 60 degrees plus theta equals to 180 degrees. 80 plus 60 is 140, so 140 plus theta equals to 180 degrees. We subtracted 140 degrees from this equation and finally found out that the missing angle theta equals to 180 minus 140, it is 40. So this angle theta equals to 40 degrees. Angle theta it is defined also as angle A and B that is equal to 40 degrees in its size. So this is angle A and B that is equal to 40 degrees in its size. In the next step we did the construction, that is to say from point B, we draw line segment BD on CA. Again, we draw line segment BD on CA in such a way that BD equals to BA. Again, BD equals to BA according to our construction. Yeah, BD equals to BA or AB. So we have here two equations. From one side, from this equation, we know that AB equals to NB. But from this equation, AB also equals to BD, so we can write here that AB equals to BD also. And from this equation, NB equals to AB equals to BD, we will derive that NB equals to BD. Okay, NB equals to BD. So here, NB equals to BD. Those two sides are equal to each other. Then we focus on triangle ADB, so I copy triangle ADB in a new page and we analyze it. Actually, we focused on triangle ADB. Okay, so I copy triangle ADB in a new page and we analyze it. So here this is triangle ADB that I copied from the original drawing. Angle DAB equals to 80 degrees and AB equals to 8 dB according to our construction. Again, angle DAB equals to 80 degrees and AB equals to dB according to our construction. Again, according to the symbol that in front of those two equal sides, they are equal angles. So those two angles must be equal to each other because they are located in front of those two equal sides. But this angle equals to 80 degrees, therefore the other angle must be also equal to 80 degrees. That is to say, we found out that angle ADB equals to 80 degrees in its size. This is angle ADB that is equal to 80 degrees in its size. We continue to focus on triangle ADB. We define the missing angle here as theta. The sum of the angles in triangle ADB must be equal to 180 degrees. That is to say 80 plus 80 plus theta. In total, they must be equal to 180 degrees. 80 plus 80 is 160, so 160 plus theta. In total, they must be equal to 180 degrees. We subtracted 160 degrees from this equation, and finally found out that the missing angle theta equals to 180 minus 160, it is 20 degrees. This is the missing angle theta that is equal to 20 degrees, but angle theta it is also defined as angle ABD. So angle ABD equals to 20 degrees in its size. This is angle ABD that is equal to 20 degrees in its size. So here we have the small angle ABD or DBA equals to 20 degrees in its size. But the big angle MBA equals to 60 degrees in its size. So the big angle MBA minus the small angle DBA must be equal to the missing angle MBD. Okay, the big angle minus the small angle equals to the missing angle MBD. So I write it down here. That the big angle MBA that is equal to 60 degrees in size minus the small angle DBA that is equal to 20 degrees in size must be equal to the missing angle MBD. So 60 minus 20 is 40, so we found out that the missing angle MBD equals to 40 degrees in its size. This is the missing angle MBD that is equal to 40 degrees in its size. In the next step we focus on triangle MBD. We have already found out that angle DMB equals to 40 degrees, and we just right now found out that the angle MBD also equals to 40 degrees in its size. So I copied triangle MBD in a new page and we analyzed it. This is triangle MBD. Those two angles are both equal to 40 degrees, and according to the rule that in front of equal angles in the triangle there are equal angles, in front of equal angles in the triangle there are equal sides. So those two sides that are located in front of those two equal angles must be equal to each other. That is to say, side DM equals to side DB. DM equals to DB. So we can write here the DM equals to DB, and here side DM equals to side DB. Those two sides are equal to each other. Okay. In the next step, we join points D and N together by a straight line, and we focused on the green triangle, triangle DNB. So I copied triangle DNB in a new page and we analyze it. This is triangle DNB that I copied from the original drawing. What is the size of angle NBD? This is actually angle NBD. It is very easy to see from the drawing that this angle NBD equals to 20 degrees plus 40 degrees, okay? So angle NBD equals to 20 plus 40 is 60 degrees. So this angle NBD equals to 60 degrees in its size. And we have already found out that NB equals to DB. Here, NB equals to DB. Okay. Here, side NB equals to side DB. Those two sides are equal to each other in triangle NBD. According to the same rule that in front of equal sides in the triangle there are equal angles, we will get that those two angles must be equal to each other because they are located in front of those two equal sides. So if this angle is theta, then the other angle must be also equal to theta. The sum of the angles in triangle NBD equals to 180 degrees. That is to say, theta plus theta is 2 theta, so 2 theta plus 60 degrees equals to 180 degrees. Okay, we subtracted 60 degrees from this equation, and finally found out that 2 theta equals to 180 minus 60, it is 120. So 2 theta equals to 120 degrees, we divided this equation by 2, and finally found out that the missing angle theta equals to 120 degrees over 2, it is 60 degrees. So this angle theta equals to 60 degrees, and this angle theta also equals to 60 degrees. Therefore, in triangle NBD, we have three angles that all of them are equal to 60 degrees in their sizes. Therefore, triangle NBD is an equilateral triangle. Okay, triangle NBD is an equilateral triangle. And you know that all the sides in any equilateral triangle must be equal to each other. So in the equilateral triangle NDB, side ND equals to side DB equals to side BN. Okay. So here, the equilateral triangle NBD, side DN equals to side NB equals to side DB. Side NB equals to side DN equals to side DN equals to side DB. Then we focused on those two equations. From one side, DB, from this equation, we know that DB equals to DM. DB equals to DM. But from this equation, we will derive that DB also equals to DN. So we can write here that DB equals to DN. And from this equation, DM equals to DB equals to DN, we will derive that DN equals to DN. DM equals to DN. So here, side DM equals to side DN. Those two sides are equal to each other. In the next step, we focus on this side of the straight line C8 point D. So which angles we have with this side of C8 point D? We have this angle that is equal to 80 degrees. This is one angle out of three angles of the equilateral triangle DNB, therefore it must be equal to 60 degrees, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. So, again, this is the straight line CA. On this side of the straight line C8 point D, we have one angle that is equal to 80 degrees, the other angle equals to 60 degrees, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. 80 plus 60 is 140. 140 plus the missing angle must be equal to 180 degrees, according to the rule that I mentioned. Therefore, the missing angle must be equal to 40 degrees. In order to complete the sum of the angles on this side of the straight line C8 point D to 180 degrees, the missing angle here must be equal to 40 degrees. Therefore, that is to say, angle NDB, this angle must be equal to 40 degrees in its size. In the next step, I copied triangle DMN, this triangle DMN in a new page, and we analyzed it. So this is triangle MDN that I copied from the original drawing. We just right now found out that angle MDB, this angle MD, it is actually angle MD, angle MD. Here it is actually angle this is angle NDM. This is angle NDM that is equal to 40 degrees in size. Okay? This is angle NDM. So here, this is actually angle NDM that is equal to 40 degrees in size. So this is angle NDM that is equal to 40 degrees in size. And we already found out that dm equals to dn. Here, dm equals to dn. That is to say, those two sides are equal to each other. Again, according to the same rule, that in front of equal sides in the triangle there are equal angles, we get that those two angles must be equal to each other because they are located in front of those two equal sides. So if this angle is theta, then the other angle must be also equal to theta. Theta plus theta is 2 theta, and 2 theta plus 40 degrees must be equal to 180 degrees. We subtracted 40 degrees from this equation, and finally we found out that 2 theta equals to 180 minus 40, it is 140. So 2 theta equals to 140 degrees. We divided this equation by 2 and finally found out that the missing angle theta equals to 140 degrees over 2, it is 70 degrees. So this angle theta equals to 70 degrees. Angle theta, it is also defined as angle DMN. That is to say, angle DMN equals to 70 degrees in its size. So here, this is actually angle DMN that is also angle theta that is equal to 70 degrees in size. So this angle DMN, the big angle, equals to 70 degrees in its size, but the small angle DMB equals to 40 degrees in size. So the big angle minus the small angle must be equal to the missing angle, angle theta. Again, the big angle DMN minus the small angle DMB must be equal to the missing angle, angle theta. Repeat again, the big angle DMN that is equal to 70 degrees in size minus the small angle DMB that is equal to 40 degrees in size must be equal to the missing angle, angle theta, that is also defined as angle NMB, that is the angle that you are looking for. So 70 minus 40 is 30 degrees. So finally I found out that the missing angle, the angle theta that is also defined as angle NMB, it is equal to 40 degrees in its size. And that is the answer to the question. Okay, thank you very much.